Howdy, my name's Dustin Kirkland. I want to say I genuinely appreciate each and every one of you for being here while Kelsey Hightower is giving a keynote in Moscone South. So it means quite a bit to me, each and every person who showed up here to listen to this, learn a bit about how Google is approaching hybrid cloud computing, and maybe see some demos at the end. Now, I do want to apologize a little bit for this title, for being about as vague as you can possibly be in the title of a presentation. And that was actually sort of the fault of the fact that we were releasing GKE OnPrem as sort of a big reveal, a big surprise in the keynotes on Tuesday morning. So this is the title that I really wanted to have for this presentation, and this is really what we're going to talk about. We're going to talk about how hybrid cloud solutions actually apply to enterprise IT, and all that is framed now that we can talk openly about what GKE, Google Kubernetes Engine, on-prem in the data center, in the enterprise, actually means. So I'm Dustin Kirkland. I joined Google about 3 months ago as a product manager on the Kubernetes team. I've been around Kubernetes and open source. I've been around Kubernetes for a couple of years now. I've been around open source for almost 20 years, having started at IBM, working with big enterprises. I spent the last 10 years of my career working on Ubuntu, developing and building Ubuntu as a cloud operating system, and have really shifted gears at this point to bring Kubernetes technology into the enterprise, and doing that with Google Cloud. So the obligatory safe harbor slide, I think this goes without saying, but this is Google Next. The conference is literally called Next. This is what we're doing next. This is a peek at where our roadmaps are going for our products, where our solutions are headed for customers. I've spent every minute of this week not in a presentation with customers, and that's been dozens of customers who have teamed up with me and my fellow product managers to help drive those products in the direction that enterprises need and actually want. So what you're going to see here is a look at where we're taking GKE OnPrem, and safe harbor guarantees about how things might change and evolve over time. This is a good slide to take a picture of, definitely. All right, so point number one. Bringing Google Cloud technology on-prem is an absolute game changer for IT. This was the initial premise for this presentation. Not premises, which is the physical place where we're going to bring this stuff, but this is the premise. This is on which we're basing this entire approach. And I had to go and add this slide just this morning. A tech journalist, Ben Keeps, who I've long enjoyed his takes on technology, he tweeted this out, just saying that he sees this particular announcement, GKE OnPrem, as perhaps the biggest announcement this week. And this made me very proud, in part because of how much I respect Ben's insights into the industry, but just how simply and eloquently he said this, and the fact that that's exactly the point that I hope to make, one of the points I hope to make here. So GKE OnPrem. First of all, hopefully the name describes it all. It's Google's Kubernetes engine. We've taken Kubernetes, open source Kubernetes. We've built it in the opinionated way that we, Google, want to run Kubernetes and host that for our customers, for our users of Google Cloud who want a curated hosted experience. Now, that's not the only way you can use and run Kubernetes. There's lots of ways you can use and run Kubernetes. There's over 100 distributions of Kubernetes. You can take it and build it yourself. I have. It's fun. But sometimes you want someone else to worry about managing that. Running that data center, that hardware, those VMs, securing the entire stack, providing the updates, the security, the maintenance over time. And that's what GKE is, Google's hosted Kubernetes engine. And of course, our competitors have their own offerings. What we're doing here is we're literally taking the same bits, the exact same bits that we use and we run inside of Google's data centers to provide GKE, Google's hosted version, but we're going to do that on-prem in a data center, wherever it is that you want to run GKE. The asterisk here is part of the safe harbor. I'm required to tell you this is now an early access program. And I have a URL for you at the very end where you can go and sign up to have early access to this technology and these features, this extension of Google Cloud itself. Now, what is it? Fundamentally, this is, I think, all in one slide. This says just about it all. It's a single pane of glass that gives you real visibility, administrative visibility, monitoring and logging visibility across workloads running in Google Cloud, GCP, Google Cloud Platform, as well as on-prem in your data center. You're able to orchestrate and manage those workloads, those containers, just the same, whether it's on-prem or in the cloud. The operating model is consistent, and I think that's important. It's really important. There's a lot of variability in the way that Kubernetes is used, and there are some ways that are maybe attractive from one perspective or another. What we've done, we think, is we've put a lot of effort into the UI and the UX, the user experience, for how container orchestration should look inside of Google Cloud, and now that's available on-prem as well. But the operations is really at the heart of it, right? Google's site reliability engineers, SREs, are absolutely world-class when it comes to taking care of your technology inside of our data centers. But now we're using those same tools to install and configure and automate and update, maintain, and deploy that on-prem the same way we do that in Google Cloud. The environments are consistent, and consistency is super important when you're programming against APIs, knowing that those APIs are going to be the same in one place as well as another, that those operating system images are available both hosted in the cloud and on-prem, updated, maintained, secured, and that the same components are available in one place and another. Now, the Google Cloud is quite rich in terms of how many different features and plugins there are and how tightly those are coupled. And over time, we're working to bring as many of those as possible on-prem as well. We're starting with Kubernetes itself, the core orchestration of containers itself, and then you can sort of imagine the other things that might make sense to run alongside that inside of your data center. But we go beyond that. So there's automated operations, but there's also management and help with that. And so we're offering full and partially managed Kubernetes. Where the real magic is in the automation, in the intelligence that we've built over time as to what it takes to keep a node up and healthy, running, predictive when that node is not going to be healthy at some point in the future so that we can take corrective action. One of the most beautiful things about Kubernetes from a technology standpoint is that it was designed with this in mind, right? I've been around Linux and open source software for a couple of decades, and the number of projects that add the sort of health monitoring after the fact, that's almost the de facto standard. Kubernetes is sort of the exception in that it was built so that updates and upgrades could happen with zero downtime. It's quite an elegant concept, but it's really simple at its core. Whenever we want to upgrade a node, we take that node out of the pool of eligible nodes for workloads to be scheduled to it, so that no new workloads show up on that node. We then drain that node of those workloads, move them elsewhere. Then we can take that node offline, do an upgrade, and then in some cases we kill the node and we start a new node. All of that's built directly into Kubernetes itself and has been from day one. So from cluster health, auto repair, these are services that Google provides to GKE, and we're bringing to GKE on-prem as well. Okay, so that's the first section of the talk. As the biggest announcement, I think, here this week, GKE on-prem is an absolute game changer for enterprise IT. The second section of this talk is really the customer empathy section of the talk. Here, I think I think we've done a lot of work and research to understand why hybrid cloud actually is important to the enterprise CIO, to the IT department, to the director of a data center who has real needs to run some workloads on-prem and just can't run those in the cloud. And so I've got roughly 10 use cases that we've learned, we've studied for why and when and where hybrid cloud actually makes sense. And those 10 separate use cases sort of fit into one of these 6 buckets. I know I said 10, this is 6. We have 6 buckets, and each of the next 10 sort of apply. So for these next 10 slides, I'd like just a little bit of audience participation. I'm going to show 10 different places where we think hybrid cloud actually matters and makes sense and is a requirement in some cases. So if any one of these next 10 slides, and you can vote multiple times, it actually sings to you, speaks to your heart, just give me a thumbs up, and that will help us, especially some of the other product managers who are here in the audience, help us just understand the impact that some of these approaches actually have in your businesses. All right, so here we go. So let's just try this. Thumbs up. All right, that's all we have to do. Simple, right? You don't have to stand up, you don't have to say anything, just a simple thumbs up. Okay, so one example of a hybrid environment that I've got personal experience with is working in the banking and fintech industry where some workloads have to run next to a stock exchange, period. It just laws of physics, the wiring, the copper between, the fiber between the data center and the stock exchange, the length of that matters, and a matter of a few hundred meters makes a difference from a latency perspective. There are some workloads that need these nanosecond latencies. This is very much event-driven processing. Something happens, and then something else needs to happen. It needs to happen very close to where that first event happened, and it's real money. There's real money involved when those latencies go beyond a certain tolerance. There are, in many cases, very specialized hardware involved, hardware that's not available in the public cloud. Some of this hardware is custom-designed ASICs or very particular field programmable hardware. And highly proprietary algorithms that, for better or worse, for one reason or another, just will not move outside of an on-prem environment. Okay? Now, all of that said, there are complements to that on-prem workload that make a lot of sense in a Google Cloud. There are jobs that run nightly as a batch job. In many cases, we're talking about models that can be trained and are trained and incrementally improve every single night, but harness the public cloud to do so. Those are not time sensitive, just as long as it takes place once a night or once a week or once a month and integrates all of the transactions that have happened in the previous day or week or month, and that model improves over time. And that can be run at a much lower expense or perhaps more efficiently in the public cloud, in Google Cloud. In many cases, those algorithms are developed and tested in the public cloud, but they end up running locally and next to the stock exchange or stock exchanges. And then from an event-driven standpoint, Cloud Pub Sub is an excellent Google technology that allows you to create publications and subscriptions and take certain actions when this happens. All right, to anyone in the room, does this one, a few thumbs up. Okay, good. So let's go from the suits and pinstripes to maybe what these stockbrokers are doing at night, which is playing Counter-Strike, right, on their at home at night. So multiplayer online gaming, increasingly so, and I've worked with a number of companies that deal with massive multiplayer online gaming. Increasingly so, the online games where you're interfacing with another player, your avatar that you see on your phone or on your screen is actually a container running somewhere in the world. And the people that you're interacting with, that you're collaborating with to build a city, or you're shooting up because they're the bad guys and you're the good guys, they're actually a container running ideally in the same data center and perhaps even on the same physical machine. And it ends up being a container shooting at another container where those things are all happening inside of a data center, and it's happening like this. And all you're seeing ultimately on your screen is a physical rendering of what happens. And that's becoming more and more the standard as we play games on little bitty devices like this that have very minuscule CPU and GPU to handle all of that processing, and you're basically watching a YouTube video of yourself playing a game is what it ends up being. And all of that happens inside of a data center. Now, sometimes those happen in public clouds, and Google's got an excellent set of customers running gaming hosts inside of Google Cloud. But in some cases, those require on-prem resources. I've seen a few that need bare metal, no virtualization, bare metal. That tends to be a requirement when latencies are extremely low and there is no concern for multi-tenancy, right? And ultimately, these are apps that are containerized and running inside of what amounts to a Kubernetes or some sort of container scheduling algorithm. Now, what happens in the public cloud? What happens in Google Cloud? Well, often there's a global control plane. There's consolidated identity and billing. That's the first point of entry to either the web interface or the app interface, and then traffic gets directed to separate, geolocated perhaps, environments. Okay, so from stock exchange to multiplayer online gaming, does anyone have a business need around this, or is this just like fun? Okay, cool, a bit of both, great. So a third case is the telco base station, okay? I've spent a lot of time working with telco, and I've had the privilege to actually visit a couple of telco base stations. Has anyone ever been inside of a telco base station, underneath the cell tower? Yeah, all right, good. You can tell us what it's like, but the ones that I've seen, especially the new ones that are being built to handle 5G connectivity, involve multiple racks of servers. Typically, they're caged off in such a way that Sprint has one cage, and Verizon has another cage, and AT&T has a third cage. And inside of each of those cages, there's a rack of hardware. In a small cell tower, it's a half rack, and some of the big ones, it's multiple racks of real physical servers cranking the data that's going to your phone and from your phone. In some cases, and these are local applications that run inside of each cell tower. There are content distribution networks, caching of data. We're watching more and more videos on our phones. I certainly enjoy watching the World Cup. I did a lot of that from my phone. Much of that data was being cached at the local cell tower when you're watching that over a 4G connection, for instance. And these are largely third-party applications, not developed by the telco, applications that they buy to handle the routing of SMS messages and the playing of content, and simple stuff like making phone calls, right? And there is a massive amount of computing power necessary to do that, and it has to be done at the cell tower. It has to happen at the cell tower. Now, what's really interesting about this is that this is a case where there's typically lots of computing power and a huge pipe of data flowing from that cell tower back to the data center or to the cloud. And so this is definitely a case where we've seen the vendors in this space wanting Kubernetes or something like Kubernetes to handle the orchestration of those many and varied apps that are being developed and released and patched and updated at cycles that are asynchronous with the rest of the development cycles, and certainly with one another, right? You've got vendors in that cell tower from lots of different companies. Now, what happens inside of Google Cloud could be the control plane again, certainly the handling of the remote management and updates. When you've got tens of thousands of these cell towers rolling out updates, requires a very centralized management control plane. And then consolidating the logging and analytics, being able to audit those, search those, detect failures, train models on when some hardware is about to fail, and you have to roll a truck out there to replace some hardware. All right, so telco industry. Has anyone seen this? Yeah, exactly. this need for hybrid computing. So video transcoding, these are in no particular order, but video transcoding is a little bit related to that multiplayer online gaming situation, in that it's in the media and entertainment industry. But we've seen a ton of video transcoding algorithms being implemented on top of Kubernetes. It's a perfect platform for dividing up massive jobs of transcoding. Typically what happens when some video needs to be produced and delivered to all of our devices, we've got many and varied devices just here in this room, from our phones to our laptops to iPads or our tablets. Each of those has a different resolution, and in many cases the video is transcoded for literally every different resolution that it might need to be transmitted to, just so that it can be done as efficiently and optimized as well as possible for your particular environment. Now there's the fun and exciting things like movies in 3D and 4K, and working with some of the interesting video production houses in Hollywood. And then there's the really boring stuff, which is actually most of the video in the world. And it's the security cameras that are around every public place, every shopping mall, hotel. Much of that video transcoding takes place first on-prem, and then some of it is archived to the cloud. Samples of it is archived to the cloud, or there's cold storage being stored in the cloud. But it often takes a local transcoding job to handle the massive amount of data. So again, this is just laws of physics. The data can't transfer fast enough to the public cloud. Some of that needs to be done local and on-prem. But once it gets to Google Cloud, some of the Vision ML APIs that are being developed inside of Google Cloud are absolutely amazing. If you've used Google Photos, I've been blown away by going through 20 years of photos that I've uploaded to Google Photos, and I was looking for this picture of a watermelon that in college we blew up, because it's fun to blow up things when you're in college in Texas. And so we blew up a watermelon, and we were laughing about this, me and some buddies, at our reunion some time ago. And I just wondered, can I find that picture? And sure enough, I typed in watermelon. I found about 24 watermelon pictures over the years, and it was amazing. One was like a dress my daughter was wearing with like little watermelon cartoons on it, and Google Photos figured out that was a watermelon, and sure enough, we found the watermelon. We blew up, and that was a fun time. But the fact that once you get that data into the cloud and you can run those algorithms, video transcoding is extremely powerful when coupling on-prem with public cloud. So video transcoding, has anyone had video transcoding jobs that they've needed to run on-prem? Yeah. So retail. I think I've met more retail customers this week than maybe ever in my career. And I've dealt with some big retailers, but this particular week has been an extremely enlightening and interesting set of conversations around retail computing. And the retail industry, as much as as we buy things online and they get delivered to our house, there still is this massive brick and mortar retail industry, and it's not going anywhere. And in fact, that retail industry is investing heavily in clusters of servers and computers there on-prem inside of a shopping center. Almost every shopping center, whether it be a mall or a strip mall or just a set of stores, shares a little bit of compute, typically provided by the landlord or the owner of that retail, who usually owns a few of those and has a very similar software and hardware setup spread across those different things. And whether it's a giant big box retailer or it's a small chain of stores, there's consistency in the hardware and software that gets rolled out. So there's typically, whether you realize it or not, there's typically a cluster of servers in the back of the shopping center that handles a bunch of local apps. And we've already talked about video transcoding, but there's about a dozen cameras per what was the number per 1,000 square feet to cover that much area, and there's a reel of tape. It's not tape. A reel of hard drives recording that, storing those recordings locally, so that when there is a problem and they need to give off that data to local law enforcement, they can do so, and that's all local. That hasn't been transferred. And then there's cold storage that happens in the cloud and in archive. And then there's inventory management, some building automation, the HVAC or the lighting, being able to handle and control that. In some cases, there are city regulations that some of that needs to happen and be able to happen locally in the case of an emergency, and has to have a fallback plan when it can't connect to an internet connected service. And of course, the point of sale system. The heart of every business is a point of sale system. Typically, your credit card transactions are logged locally. They're batch sent to the payment processor, but there's a backup kept for some amount of time just in case something happens. You know, you've probably seen that credit card transaction that didn't show up for a few weeks or a month or two, but then showed back up, and it was because someone had to go back and check an audit log, found something missing, and was able to pull that off of a second copy or a local copy perhaps. Now, all that said, Google Cloud offers a real complement to this retail cluster, whether that's a global web presence, being able to direct that traffic geographically to the best possible location or server. Certainly cloud storage for the video and those transactions, the auto ML, and the insights, the buying patterns, the user buying patterns. There's been a number of good sessions this week about the retail industry. So retail, sorry. Anyone here from retail? Or sorry, let me not ask anyone here from retail. Does this use case speak to some of your needs? Yeah. Smart buildings and smart cities. You know, one of the biggest places I think we will see in this next decade a real market improvement in our life is through automation, safety, improvements, technology-driven improvements in the way we live and interact with one another. And that can be in both rural environments as well as highly dense environments like this. And this really starts with smart buildings and smart cities. So just about everything that I said about a retail shopping center that has a rack of servers doing things that have to be done locally, as well as most of what I said about a telco base station with some applications that need to run locally. If you go to any of these high-rise modern skyscrapers, there's a rack of servers in the basement doing building automation and certain transactions that have to happen within that building itself. And I've said security I don't know how many times now, but it ends up being quite a bit of security feeds, HVAC, and just running the operations of the building itself. Now, the smart part of smart buildings and smart cities is using AI and ML to train models and improve the performance and the operation of some of those aspects that we come to depend on from a technology and infrastructure perspective. Training those in the cloud and sending the models, the trained models, back down to the clusters to implement is really an interesting handshake. So smart building, smart cities. This one might be a little bit on the fringe, but does anyone have any experience in this space and see hybrid computing? Yeah, that's good. So data provenance is one that I think we've all experienced this year. Anyone who's had anything to do with GDPR, and then prior to GDPR, any of the other personal privacy protection, either legislation or regulations, and in some cases just our own processes that we have in the enterprise around where data can be, how long it can live, how it needs to be encrypted and treated. And in some cases, there are simply legal obligations, there are compliance requirements around where that data lives. And no matter how secure and encrypted at all levels Google Cloud actually is, there's some processes that just require some data to be stored locally and on-prem. And we will continue to improve the security and the compliances and the list of compliances. It's actually quite an impressive list at this link here of compliance audits that Google Cloud has passed. We'll continue growing that, but there's some data that for one reason or another needs to live somewhere else, and perhaps it's inside of a country. In some cases, it may just be for liability limitation. There's an insurance policy that a company might have where their insurance policy is different depending on where their data is stored, or that's what their auditors have told them. Now that said, inside of Google Cloud, we do have a really rich security feature set. Your data is encrypted at every single level, all the way down the stack of virtual machines or booting in trusted boot environments. And then there are extremely fine-grained identity and access controls, RBAC access controls around that you have control of as to, in your organization, who can access given buckets of data. So from that perspective, this is a case where some data lives in some places and some data is replicated elsewhere. Some data is encrypted with a set of keys that stores the data, but it's protected unless those keys are available. So from a data provenance perspective, this is another driver for some hybrid use cases. Does this resonate with anyone? Wow, it's a popular one for sure. So then we go toward lift and shift. Lift and shift being maybe some traditional workloads that have long lived in an enterprise data center, but for one reason or another, you'd like to move them to the cloud, possibly even in the other direction. In that it can really go either way. I've seen and I've worked with a couple of large customers moving virtual machines to the cloud. Google acquired a company called Velostrada, and I'm the product manager associated with Velostrada as we're working to integrate Velostrada into a bit tighter into Google Cloud. But Velostrada has some technology that will take a VMware virtual machine image and live stream that image to Google Compute Engine without downtime, and actually move that VMware image into a VM in the public cloud, in Google's cloud. And it's really quite impressive. It's a great demo, and it's something that we've helped organizations move thousands of legacy applications running in VMware inside of their data center into a hosted cloud environment. I've certainly been in a data center with old, dusty machines that no one's quite sure how it's still working because the fan makes a noise about 60 times a second, and at any point it could fall over, and boy, that's just going to be a bad day. And so moving some of those workloads into the cloud tends to be a priority. And in some cases, this is what people really mean when they mean hybrid cloud, being able to just move a good old VM from one place to another. And we're seeing more and more of that with Kubernetes as these applications are lifted and shifted. They're actually moved and improved. They're modernized as they actually move into a cloud, and there are some advantages to be had by moving them into a container, not having to worry about kernel updates, for instance. And the real point is that most legacy software actually predates the cloud. That's sort of the definition of legacy at this juncture in time, anyway. And from that perspective, some of those workloads can't or won't or just are not well suited to moving to the Google Cloud for one reason or another. And that might be an impetus for, in some cases, using both on-prem for some workloads and public cloud for other workloads. So from a lift and shift perspective, is this an initiative within anyone's organization? Yeah, we see that quite a bit. So this is a fun one, and I actually know a really interesting young man. He's interned for me a couple of different times, but in his last internship, he had this really interesting job, which was to create a calculator that would determine for a given job. He was working for a company that did a lot of large-scale AI/ML jobs that cost tens of thousands of dollars to run just one time. Just running this job one time, it was tens of thousands of dollars. And his job as an intern was to figure out the cheapest way to run that job, meaning which cloud, whether they use GPUs or TPUs, how big the instances should be. And that tool saved this company maybe 20%, maybe $2,000, $3,000 for each job if it could find the cheapest right way to run it. And in some cases, now their organization was entirely public cloud, but I've seen this model actually work where sometimes it makes more sense to simply run a job on-prem for one reason or another. In other cases, it makes more economic sense to run that in Google Cloud, for instance. And so, you get this sort of decision tree of when to do which, and it's actually quite simple, wherever it's cheaper, wherever it's less expensive or costs less. And I call that the economic arbitrage. It's like we're going to arbitrage this job and run it where it's most efficient. Does anyone have to make this decision, or has an algorithm to make this decision for them? Yeah, it's a real driver for business, and it can show you where your efficiencies are available. So this is kind of the classic dev, test, CI/CD into prod. I've worked with organizations that do all of their development in the public cloud, but then run their production servers on-prem. And I've seen exactly the opposite. We do all of our development on our laptops, on our Macs, on our Linux machines, but then we run and host host our production servers in the cloud. And so, you know what? We're not prescriptive about that. From this perspective, I'm certainly not prescriptive about it. Whatever makes sense. Bringing GKE OnPrem, for instance, gives you the ability to do either. You can use the on-prem cluster for your dev and test, and GKE for production. I certainly think that makes a lot of sense, but you could just as easily do it in the other direction and send your load balancers, your traffic elsewhere. And so I think this is kind of one of the classic hybrid models, using a bit of public cloud, a bit of on-prem. I'm guessing a few people have experience with doing this for sure. Yeah. And then finally, the last one is, and I've seen this now from a number of banks and some regulated industries that are deemed just too big to fail, that they're actually spreading workloads across multiple clouds, where running in Google Cloud is great, and then having another plan is actually is required by industry regulations, just in case. And so there's a lot of reasons that could go here, but I think this is a different type of hybrid cloud. This one isn't necessarily on-prem to Google Cloud. It certainly can be, but it could be from other clouds to Google Cloud. So does this one hit home with anyone? Yeah. Okay, so that's our 10 use cases. I've studied each of these, and we've put together, from a product and strategy team, put together quite a number of critical user journeys through each of these, and we are working from a hybrid cloud computing standpoint with these in mind. So maybe at the end I'll ask if there's. I'll just ask right now. I've got just a couple of minutes. Is there any major use case that I've missed here, or do these pretty much cover it? Yes. Research Institute. GPU hardware. Yep. So that's a great example. They've got a lot of hardware that they've invested in, GPU hardware in a research institute, and it's sort of there, and you want to use it because it's there, but you want to take advantage of newer GPUs, perhaps newer hardware, and the burstability of public cloud. Good, thank you. Okay, so the third point to make here is that we really do have a world-class cloud. I hope that you've enjoyed your week here. I think we're starting to wrap up. I've found this an amazing 3-day exhibition of just the innovation and inspiration of how much work my colleagues, my engineers, put into what they do every day. I've learned about corners of Google that I didn't know existed. Some of the announcements were as new to me as to you here. Hopefully you've been educated a little bit. But I think hopefully the previous section shows you that we really know, we're really coming to understand what hybrid cloud is by classifying this, understanding these use cases, having this sort of feedback. But I think that the inverse is actually true as well. I think hybrid actually knows Google and actually uses Google in a lot of different ways. If we start with like the last 10 to 15 years of Google products, enterprise products, it goes from G Suite, from using Google Docs and maybe Hangouts or mail calendaring inside of the enterprise, while the enterprise still has its own IT data center. This is a piece of IT that used to be in servers stored locally, storage maybe for documents. Who remembers emailing documents around? Boy, what a miserable time it was to work in this industry when everybody would get a copy, their own copy of a doc. And I mean, how did you do collaborative editing? I couldn't live without that today. It's like going back to a typewriter. The leap is almost the same, but now that's all stored essentially in Google's public cloud, but secured and cordoned off. To Android Enterprise, being able to use those same apps securely on a phone, managed by an IT security organization, your own IT security organization, who does that through Google's technology, and then it's really coming to Google Cloud as well. The enterprise leveraging Google Cloud. And I'm here to really just talk about Kubernetes Engine, but there's so many of these products are actually quite applicable to the enterprise and bridge that gap. And that's the point here. We're working hard to bridge the gap between your data center and Google's services. And I say services and not servers because we really are looking at this from a services perspective. We produce services that you can consume, APIs that you can talk to, applications, but those applications end up being Google services, in fact. And GKE OnPrem is super special here. This is really the first time we're bringing Google's software into the enterprise data center. The only other example we can really think of here where Google's done something similar is the search appliance, which was actually a physical hardware appliance that you installed in your rack and indexed your data, documents, websites on your internal intranet. That was a physical appliance. This is different. This is software, Google software, that runs inside of your enterprise data center. And that's a game change. That's really different. I can't understate how important that change actually is. And so wrapping this all up and bringing it together, I think if you were going to take a picture of one slide, this is the one that I think says it all here. If you really treat Google Cloud as an extension of your own data center, just imagine how powerful your data center ends up being. It's sort of the analogy of your phone that has access to the internet, and suddenly this tiny little thing has access to basically all of the information that has ever been created in the history of mankind, and this is your interface to it. If your data center itself is connected to Google Cloud and using Google Cloud technologies, just imagine how powerful that data center becomes. I'm actually going to skip this and go straight to a demo. I think you guys would rather see a demo than an architecture slide. Well, very briefly, this is the sort of architecture. I've whitewashed all of the customer names and the customer code names off of this, but this is essentially a retail use case, a retail customer who's using a blend of Google Cloud Platform and their own online enterprise data center, as well as some technology slated to run on-prem in the store on site. That's just one architecture for one of those 10 use cases that I described. But Google's customer engineering team and solutions architects can create this sort of a design by interacting with the right person in your IT organization very smoothly. Okay, so let's see a demo. So this was that single pane of glass, which was a snapshot of a web page. You want to see this in action? Yeah? Okay. I can't do demos with a jacket on. It's not right. It's absolutely not right. All right. I'm going to get rid of that. All right. This is my, my Google Cloud console. I'll blow that up a little bit. And I've got a cluster running on the East Coast somewhere. That's my one cluster. In fact, this is the cluster. This is half of the cluster that was used in Tuesday morning's keynote, the one where we had the big reveal that there's actually, this is being served on stage. Half of that cluster was running in Google Cloud. The other half was running there on stage. Now, what I want to do at this point is register an external cluster. And for this cluster, I'm going to name this cluster Cluster Palace. And unfortunately, I was not able to get the rack of hardware up here, but I do happen to have Kubernetes running on my Linux laptop right here in Palace Gold Room. So I'm registering this external cluster. I'm going to download this manifest. And I'm now on my local cluster, and I can do a kubectl get all, and you can see I've got a little Kubernetes up and running here on my laptop. Now, if I simply kubectl apply to the namespace GKE Connect, the YAML file that I just downloaded, that will set some key value pairs. And I'm going to see this is waiting for that connection to happen. And while that's happening, actually, let's go back and do something else. Let's register another cluster. And this is going to be a bare metal cluster that's running in Texas. So I'm going to download that one, and I'm going to come over to my bare metal cluster in Texas, and I'm going to kubectl apply. Let me just make sure this is up. Okay, and I'm going to wait for that one to come up, and actually, I need to do one more little thing. I need to enable a couple of services. And we're going to get to, and I'm going to need to apply my secrets. I'm going to do that there, and that there. And then we're going to kick that off one more time. All right, and what we should see in just a minute is a set of clusters and workloads that we can actually run across each of these clusters. So okay, so now that one connected. And I'm going to continue to the configuration, and I need to go and fetch a secret, a token here. And I need to get this token. Let me make sure I got the right token. So now I'm going to configure this cluster, and I need to move to authenticate. Actually, I need the endpoint first. So let me get the endpoint. Got the endpoint. I need to continue to authenticate, and I need the token, which I've got here. And I'm going to finish. And I can now see my laptop has registered. Cluster size of 1, 4 CPUs, 16 total cores. And I can now go over to the Workloads tab. And I can see my cluster. Cluster Palace is running, and I have a GKE Connect agent. Now, I'm going to deploy a workload locally using kubekittle. So now I'm on my development cluster here on the laptop. I'm going to deploy and expose that workload. And I can see that it's running, and that's its IP address, port 9876. And so I can go to here, and I can see every time I refresh this, I get a cute little, cute, look at that, an adjective and an animal. Now what's amazing is that if I refresh my workloads tab on this, I can see the pet name workload. This is running in Google Cloud, and I've got a workload here running. Okay, that's pretty amazing. Now, probably the top question that I've gotten over the last, we've gotten over the last 2 days is, can I run GKE OnPrem on bare metal? Can I run GKE OnPrem in Amazon, even though it's called GKE OnPrem? And so that question has come up over and over and over again. So what I'm about to show you is certainly not a product plan, but I'm about to show you that the GKE Connect technology, yes, it works just the same across the board. So I've got an instance running here in Amazon. And if I kubekittle get all, I can see I've got some workloads running here inside of this, inside of here. And if I go to my clusters, and I register an external cluster, and I call this the cluster AWS, simply for demo purposes. And I go over and I apply the secrets.yaml and the cluster AWS Connect. And I come back here, and voila, we are now connected. And if I continue to this and I get my local endpoint, it's important to understand this. There is a local endpoint. This is not routable. I have to have the connection agent to get to that local endpoint. And I continue, and I need to get the token. And I've got this token, kubekittle describe. And this token is unique per cluster, so I've got to copy that each and every time. And now I'm registered, and it's going to take a second for the cluster size and the cores to come up as it starts exchanging information. And we are actually out of time, but hopefully we will get to see some workloads populate here in just a second. Okay, are we strictly out of time, or can I take a question or two? We're strictly out of time. I cannot take a question or two. All right. I will be just outside the room, and I'm happy to talk to anyone about more of this if you'd like to see it.